Okay, so this is the second video for today, probably the last one for today, and this one I'm just going to work some examples, doing some simple area stuff with polygons, specifically kind of the quadrilaterals, and we'll throw the triangle in there as well. So when we do these problem-solving things, just keep in mind that there's going to be like an intermediate step. It's not going to just be a base and a height is given to you, find the area, like we did in the last video. This one's going to be we're going to have to solve for a base, we're going to solve for an area, we're going to solve for height, but it's going to take a couple of steps to do it. Whatever. Don't forget things like Pythagorean Theorem. You know, a squared plus b squared equals c squared is still a good thing to know with right triangles, you know? All right, so first problem. Oh, look at this. I went through and I put the old PowerPoint in. There we go. First things first, let's find the area of this shape right here. Now, when they say find the area, they mean really of the solid shape, not of the one with the dotted line, okay? So if you look at this, you'll notice that's a parallelogram, right? It's a parallelogram. And in a parallelogram, the area is equal to the base times the height. Well, the problem here, I know the base is from here to here, that's 6 inches, okay? So whenever I do area is equal to base times height, I know that I'm going to say that that is a 6 times the height. But the problem is I don't know what this dimension is here. That's the height that I'm interested in using. Well, that's where the right triangle comes into play. The idea is that they want us to use this right triangle to solve for h and transfer that over into here, right? That's why that was given. So it doesn't affect the area. The area is of the solid shape. It's simply there so we can solve for the height. Well, it is a right triangle, so I know that I can use Pythagorean Theorem. A squared plus b squared is equal to c squared. So 3 squared plus h squared is equal to 5 squared. And if we go through and we solve for h, and I'll do that quickly, feel free to pause at any point in time, of course, then I would have 9 plus h squared is equal to 25. I would have h squared is equal to 16 because I'm going to subtract the 9 from both sides. Now I'm going to square root both sides. H must be 4. Really plus or minus 4, but a negative 4 doesn't really make any sense, right? You can't put a negative 4 for a height. So the height is equal to 4 inches. That means the area is equal to 6 times 4, which is 24. And then for the units, because everything was in inches, and we're talking about an area here, area is always in square inches. So square units. So in this case, square inches. See, two-step problem, in other words. It's just not quite as easy as the ones from the last video. Over here, find the base of a parallelogram if the height is 56 yards and the area is 280 square yards. So here we go. Let's draw a quick sketch. You don't have to be a good artist, just have to get pretty close. There's my parallelogram, right? Here's what I know. The height is 56 yards. And the area overall is 280 square yards, right? Well, for a parallelogram, oh, by the way, we're looking for the base. Might not be a bad idea to go ahead and just label what we're looking for. We're looking for that dimension right there. Area of a parallelogram is equal to base times height. So in this case, we know that the 280 that we got was the result of taking 56 times the height. Divide both sides by the 56, and you'll get that the height is equal to 5. It's not an area, it's just a straight dimension, right? So it's just plain old yards, not square yards. The square yards is at the area up here. So if I had a 56 by 5 parallelogram, there we go. Area of that would be 280 square yards. Pretty straightforward on that one, right? All right, next problem. If I can figure out how to turn the page, here we go. Find the length of the base of a triangle that has a height of 12 and an area of 72 inches squared. Really, that's to say 12 inches, okay? It doesn't matter what kind of triangle it is because obtuse, acute, right triangle, they're all the same. What I'm interested in is the vertical height of the triangle. So I'm going to pick the one that's easiest to me. I'm going to go ahead and stick with a right triangle here. And here's what I know. The height of that triangle is 12 inches. And I know that the area total was 72 square inches. And area for a triangle is 1/2 times base times height. So I know that the area of 72 was what I got when I took 1/2 times the base, which is what we're looking for. Might want to label that, by the way. Never a bad idea to go ahead and label what you're looking for. So I'm looking for that base, 1/2 base times the height of 12. So this is just a couple-step problem if I'm going to solve for b. If I did this, what I would do is I would say half of 12 is 6. So I would really have 72 is equal to 6b. And then I would just divide the 6 out, so b would be equal to 9. 9, let's see, That's just a straight unit, not an area, so it's just inches. Okay, next problem. Find x if the area of the kite is 292 square centimeters. Well, here's what I know about kites. That the area of a kite is equal to 1/2 times the product of the two diagonals. Right? And this is the one that everybody screws up because they want to add D1 and D2. It is not an addition thing. It is a multiplication thing. Please take the time to memorize this if you want to get these problems correct. It's not hard. You just got to do it. So, the area that I got, which was 292 square centimeters, was the result of multiplying 1/2 times the diagonal of 14x minus 67 times the other diagonal, which was 8. And here's how I would do it if it was me. I would say, first things first, that half of 8 is 4. So really, I could write it like this. 292 is equal to 4 times 14x minus 67. In other words, it doesn't matter what order you multiply stuff. Just pick any two of the three and multiply them together. 1/2 of 8 is pretty simple. Let's do that first, right? Now it looks like I've got a little distributive property that needs to happen. So I'm going to distribute the 4 out. 292 is equal to 4 times 14, which would be 56x, 40 plus 16, yep, minus 4 times 67. Let's bust out a calculator for that. That would be 268. Now it's not looking too bad. Looks like I need to add the 268 to both sides. I'll move over here. So 292 plus 268 is 560. That's equal to 56x. Looks like x is 10, doesn't it? Let's divide the 56 out. X is equal to 10. I don't know, it's not really centimeters because it's involved with that, right? So just 10. X is 10. A couple more quick problems. I know I'm getting long in the video here. A couple more quick problems. These are straight off the ACT, old ACT test. You have enough material to build a fence that's 40 meters long. The 40 meters of fencing material. If you use it all to enclose a square region, how many square meters will you enclose? Well, the first things first, let's go ahead and draw a picture. That's going to help us get an idea. And here's what I know. These 4 dimensions have got to be the same. It's a square, right? If it was 40 meters of fencing that I had available, it looks like I would need 10 meters on each side, right? That would be 10, 20, 30, 40. In other words, this number here, that's really a perimeter. Okay? The 40 meters is how much fencing I have. Well, I kind of wrote off the screen there. That's a perimeter, right? So the question is, how many square meters will I enclose? Well, now we go back to, hey, what's the area? That's a hint right here. When I'm looking for square meters, it means they want me to find the area of this shape. Well, area for a square is just base times height, which is 10 times 10. It's 100, right? Notice, by the way, on the ACT example, I did that without any calculator. They give you numbers, in other words, when they give you 40, they gave you that because it's easy to break that up into 10, 10, 10, 10. And they gave you that because they want you to be able to multiply 10 times 10 easily. The ACT test is set up so you don't have to use a calculator if you can work with simple numbers like that. If you can multiply 10 times 10, whatever. Okay, so let's look at another ACT example. Keep in mind, this is set up so I really don't need a calculator. But this one's a little bit tougher. Notice it has square roots. That's going to scare some of you. If the rectangle and the right triangle in the figure have the same area, what is x in terms of A? Tough problem, right? Well, here's all I need to know, really. That's a rectangle. And the area of a rectangle is base times height. So the area of this rectangle is 3a times a, which is 3a squared. Over here, here's what I know, is the area of a triangle is 1/2 base times height, which is 1/2 times 2x times x. Well, half of 2 is just 1, so those two cancel each other out. And x times x is just x squared. That area is x squared. So, what are we going to do with this information? Here's what I know. They have the same area. That means that 3a squared and x squared must be the same thing. 3a squared must be equal to x squared. So the question is, what is x? And when they say expressed in terms of a, they just mean, look, there's going to be an a in the answer. You can't get rid of it because you don't know what it is. they're asking us to solve for this, right? So what do? To get rid of a square, I square root both sides. Well, the square root of 3a squared is really the same thing as the square root of 3 times the square root of a squared. That's just a. The square root of a square is just a. So I have a times the square root of 3. A times the square root of 3. Done. A little bit trickier, right? Probably those square roots make you a little bit nervous. One more. ACT example should be able to do it without a calculator. And the parallelogram below, the lengths are given in centimeters. What is the area of the parallelogram? You know why this one's scary? Look at that square root involved. Oh my gosh, people probably stop here. But if you know the area of a parallelogram, you realize that it's just base times height. The base is 2, and the height is 4. The answer is 8. That one is deceiving because they throw this extra information in that you don't even need. You don't need it at all. Okay? You don't need it. It's there to scare you. So, with that in mind, there's the first day. That's 2 videos that you should have just watched, about 20 minutes worth. And that's basically just over calculations and different example problems that we might do involving areas of some basic shapes in 2 dimensions.